Good morning, guys. Anjani Kumar here, dealing instrumentation subject for a final year electrical students. In a last session, we have successfully completed about LVDT. Right? So LVDT means linear variable differential transformer. Right? I just want to give brief glimpse of this LVDT. After that, today's session will start the concept of strain gauge. Right? I just want to give brief glimpse. Right? So what is LVDT? So LVDT means linear variable differential transformer. Alright? So why we can call it as LVDT? Means LVDT is an inductive transducer. It can be used to measure the displacement. Right? So the displacement can be measured by changing the flux, changing the inductance, by measuring the changing inductance or changing flux, whatever it may be. Right? So what is that statement says that LVDT means linear variable differential transformer. Transformer means like a transformer, that LVDT also having one primary winding, two secondary windings. Alright. So what is a differential? So differential means whatever the output that you are getting, it's a difference in the outputs that getting out from the secondary voltages. Right? You have a two secondary voltages, right? So whatever the output, which is equal to the difference in the two voltages, right? What is a linear variable? Linear means whatever the displacement that you have to find, that should be a linear and linear relationship with the output voltage. That's why we are calling as a linear variable differential transformer. Right, we discussed each and everything, construction, what are the metals, what are the constructional parts, and all these things that we discussed clear. Right? So how you can find the displacement means we have a construction like this. I'll explain simple way. It's a primary winding, two secondary windings. We have a nickel, we have a soft iron piece. Alright, the secondaries, whatever the turns, two secondary windings that has the same number of turns and equally displaced from either side of the primary. Right, now whatever the soft iron piece at null position, x is equal to 0 position, then whatever the voltage across E1 and E2. How the voltage develop means whenever the alternating current is applied to the primary winding, so what happened, there will be a flux will be developed. These flux links with a secondary, definitely there will be a induced EMF. So that one EMF we can call it as E1, another EMF we can call it as E2. Now your soft iron piece at null position, there will be no change in flux, so whatever the generated EMF E1 will be equal to E2. So that means whatever the output voltage delta E is equal to E2 minus E1. At null position, what is the output voltage? 0. Right. Now you are moving your soft iron pieces to your left position. So left position means left position. So that means E2, E1 should be greater than E2 na. So whatever the flux in a left position, the secondary winding turn is nothing but E1, right? So whatever the flux near this secondary, it should be very high when compared to this another secondary. So what happened, that whatever the voltage that are developed here, it should be greater than the voltage developed here. That means what about is delta E, change in voltage is nothing but E1 greater than E2, that means positive. So you are getting the voltage is positive means whatever the phase that you are getting, which is equal to the phase that you are applied voltage E phase lo unte, whatever the output also the same phase that you are getting. Right? Now you are moving your software in pieces to the right hand side. So then what happened? The number of flux change in flux in E2 very high when compared to the E1. So that means what about the delta E is equal to E2 greater than E1. That means delta E you are getting E2 minus E1 minus E2. So that means it's a negative value. So that means whatever the voltage that you are getting from LVDT, that is phase opposition to the applied voltage across the primary. That's a simple thing that we need to. How this change in voltage you are getting means by varying your displacement. Definitely your displacement which is converted to the voltage. So that means it's like a transducer. How the displacement varying means you are linearly varying, not rotational, not up and down and all these things. You are linearly varying your soft iron pieces. That means whatever the voltage you are getting is a linear relationship. That's why we are calling as a linear variable differential transformer. I hope it's clear, right? We discussed about what are the materials, right? Nickel, cadmium and all these things that we discussed in the last session. After that, what are the advantages? Definitely it will be used for find out the small change in a displacement, right? Smallest change up to 0.03 also. 0.003 also, right? It will be used for a large displacement also, 230 to 300 mm of displacement also we can find these type of LVDT, right? There are more steel protection system is there for electrical shocks and all these things, rugged construction. It's these are the things that we discussed in our last session. And disadvantages also there. For a large measurement of displacement, it reads some errors also, temperature variations, vibrations also. LVDT got some troubles, right? Some applications also. It can be used for primary transducer, and also it can be used for secondary transducer also. So primary transducer means by giving displacement directly it will convert it to the voltage, right? Secondary transducer means, per suppose if you want to find the force which is converted to displacement first, then the displacement which is converted to voltage. So here LVDT is a secondary transducer, like a board and tubes, alright, all these things. So it can be used for a primary transducer and it can be used for a secondary transducer also. This is about our last session. We discussed about LVDT. This is very most important concept. Definitely you will get in this unit. Definitely you will get this type of question in your end examinations. Hope it's clear, right? Now another important concept that is called a strain gauge. Right. So under the strain gauge, so what are the things that we need to discuss is, what is a strain gauge? Right. So mechanism of strain gauge. Right. After that, working principle. Right. After that, gauge factor. Right. After that, some materials used in strain gauge. Right. So these are the contents that we are going to discuss in this session. Right. So what is a strain gauge? What is the need of a strain gauge? Right. After that, we discussed about what is the mechanism, how the operational mechanism of a strain gauge. After that, working principles. Basic working principle is that find whatever the quantity, right? After that, gauge factor. What is the importance of gauge factor? How we can solve the gauge factor, right? And some materials, right? We discussed about what are the materials that can be used in a strain gauge, right? Hope it's clear, right? So these are the contents that we are going to discuss. So before going to strain gauge, I just have some question and the answers, right? And the first question. Right? Have you ever thought, is it necessary to find how much amount of stress that aeroplane wing that can handle until it fails? Is it necessary to find? So definitely yes. I hope it's clear. Once again I'll repeat, right? Have you ever thought, is it necessary to find how much stress on aeroplane wings that can handle until it fails? Definitely yes. Why? Because aeroplane wings are the most powerful part for a successful operation of a aeroplane. Isn't it right? So we need to, as an engineer, we should know how much stress on the aeroplane wings. Right? How you can find that stress? Right? How you can find that stress? So with the help of a sensor. So with that sensor, so we can find the stress, how much strain, how much force on that aeroplane wings for a successful operation. So that sensor is nothing but a strain gauge. Right? So aeroplane wings. Alright? I hope it's clear. Second one. Have you ever thought how the bridge companies work? Right? In a metropolitan cities or some other cities, we have a number of bridges, right? So civil engineers' duty is to find out on that bridge which point is a weak point. So definitely you should find that weak point, and some other arrangements should be fixed before the bridge breakdown. I hope it's clear, right? So in a metropolitan cities, we have a number of bridges, right? So it's our duty, it's a civil engineer's duty to find the weak points on the bridges. How they can find the weak points on the bridges before the bridge breakdown, right? So we require a sensor. So we can call it as a strain gauge to know where the weak points of a bridge. We can easily find out, right? Bridges, weak points, right? And the third one, is it necessary to find the good operation of a rail? Definitely yes. You know, in each and every rail we have two types of forces, right? Horizontal forces and vertical forces acting on the rail. So whatever the tracks that you are constructing should definitely withstand this weight, right? So for this, is there any weak portion of the track? Is that a track which can withstand the total weight of the rail, right? So definitely we require a sensor to find out the track should maintain that weight, that forces. So for this we require a sensor called a strain gauge. I hope it's clear, right? So definitely we require the continuous operation of a rail means rail is acting as a horizontal forces and vertical forces, right? So whatever the tracks, there are two tracks. So these tracks that can withstand the weight of that rail, or that can withstand the forces that are acting on that rail, right? So definitely we require a sensor whether this track is maintaining that stress or strain, we should know. So definitely the engineer's duty is that. So we require a sensor. So that sensor we can nothing but a strain gauge, right? And the third one, in some other cities some other localities, right? So the people should know that for a particular length of the street or for a particular length of a line, only only small vehicles like cars and small persons only allowed. How they can maintain? How they can know? Right? So how they can know means it's engineer's duty to find the total stress on that line. So then only they will tell that so this street or this line used for some weight person, some vehicles only that should allowed. How you can find? So for this we require a sensor called a strain gauge, right? Lines. So these are the questions. So for all these questions, only one solution, that is called a strain gauge. So that is the topic that we are going to discuss here. I hope it's clear. First, aeroplane wings. I'll tell it in Telugu, right? Aeroplane wings తీసుకున్నామనుకో. So wings is the most predominant part, right? So for successful operation of a wings, how much stress that wings can handle, that you should know. How we can find out the stress? With the help of strain gauge, right? And second one is bridges. Metropolitan cities లో చూసుకున్న నెంబర్ ఆఫ్ బ్రిడ్జెస్ ఉంటాయి, రైట్? సో బ్రిడ్జ్ కంపెనీస్ డ్యూటీ ఏంటి? సో డెఫినెట్లీ they will know is there any weak point of the bridges, right? So definitely they should find that weak point and they should fix that point before the bridge breakdown, right? How they can fix, how they can show, how they can find the weak points? So with the help of sensor. So that sensor we can call it as a strain gauge, right? Definitely. And the third one is a rail operation. Definitely we should maintain the successful operation of rail means you should construct a track now. This is the track now. So rail which is having a horizontal forces and vertical forces, right? Horizontal forces and vertical forces are present. So these type of forces your track can withstand or not. Otherwise there will be a failure, right? Lack of problems will occur. So definitely we should know whether the track should withstand that weight or withstand that force or not. So that's why we need to know the how much stress on the track, right? So that's why we require a strain gauge. In that part also we require a strain gauge called a sensor, right? And the last one, in your street or some other localities for a certain distance only small vehicles are allowed. How they can tell? How they can know? Some other people came and tested that this street belongs to some sorted weighted persons only should flow, like a small car, small vehicle should flow. How they can find? So with the help of strain gauge, how much force, how much stress that are acting on that line, right? So with the help of strain gauge. So these are the realistic points where we are using your strain gauge and all these things, right? In aeroplane wings you will see like in aeroplane wings you are placing your strain gauges here. They will tell how much force that are acting on that wings. So with that forces you require your materials for developing your aeroplane wing. So you have to choose your material, right? Bridges you will see bridges in the small part of thing that you can build here. It will show how much stress on the bridge, total overall stress on the bridge, like a strain gauge, right? ట్రాక్స్లో చూసారనుకోండి మీరు, ఇట్లా ట్రాక్ ఉంటుంది కదా, ఈ ట్రాక్లో వన్ సార్ట్ ఆఫ్ థింగ్స్ దట్ యు ఆర్ గోయింగ్ టు బి ఇన్సర్టెడ్. సో ఇట్ విల్ షో హౌ మచ్ స్ట్రెస్ ఆన్ దట్, హౌ మచ్ స్ట్రెస్ దట్ కెన్ హ్యాండిల్ ఓన్లీ. సో ఇఫ్ ఇట్ ప్రాసెస్ దెర్ విల్ బి ఏ ప్రాబ్లమ్ ఇన్ దట్, సో యూ షుడ్ గో అండ్ ఫిక్స్ దట్ వన్, రైట్? Similarly the lines also. So this is some sort of introduction to strain gauge. I hope it's clear where we are using these type of strain gauges and all these things. Alright. Now we are move on to the original concept. strain gauge which is used to measure the strain measurement. Measure the strain measurement. Strain is nothing but either force also. Strain, stress or compressed, whatever, these are the force. How much force acting on that, how much strain on that. Alright, the strain gauge which is used to measure the strain measurement. Alright, before going to that strain gauge, so we need to know a few definitions, right? The first one is, so what is a stress? Stress is nothing but the force applied on per unit area of material. Right? So force applied per unit area of a material. So we can denote it by sigma. Sigma is nothing but stress. So that is nothing but force applied by per unit area. So whatever it may be. So sigma we can call it as a stress. Stress is nothing but the force applied on a cross-sectional area of a conductor. If it is a conductor, how much force that you apply, that is nothing but a stress. How much tension on that. Next, second one is strain. So strain is nothing but extension per unit length. Right? Strain is nothing but extension. Strain means extension per unit length. This is a simple definition, right? Before going to strain gauge, we need to know what is a stress and what is a strain. Strain is nothing but extension per unit length. Right? So we can denote it by epsilon. So what is a strain? Extension per unit length. What is that extension? If length is L, what is the extension? Delta L. So what is original length? L. So this is called as strain and this is called as stress. So what is a stress? Stress is nothing but the force applied per unit area of a material, right? Per unit cross section of a material, whatever it may be, right? So the force by area. So what is a strain? Extension and its length, per unit length, whatever it may be, right? So we can denote it by, strain is denoted by epsilon, delta L by L. Alright. So what is the relation between stress and strain? There will be one formula denoted by Young's modulus. So what is a Young's modulus? It can be denoted by this like a star connects star. So what is a Young's modulus? Denoted by sigma by epsilon. So the relation between a strain and a stress is nothing but Young's modulus. That is nothing but strain by stress. Right? So these definitions are enough. So before going to know strain gauge. So what is a strain gauge? Now we'll discuss about the working principle of a strain gauge. Right? So working principle of a strain gauge. What is a strain gauge? Right? See, in a metal conductor, if you stretch it or compressed, its resistance will change. Right? So you can measure your resistance with the help of Wheatstone bridge, or else whatever the indicating meters, whatever the meters that you have, you can measure the resistance, change in resistance into voltage. So how the voltage came, how much stress that you applied. See, in a metal conductor, if it is stretched or compressed, its resistance will change. You know the transducer, working of a resistive transducer. If the resistance change, the change in resistance you can find with the help of Wheatstone bridge. Right? So whatever the output voltage, which is analogous to the how much stress that you applied, how much force that you applied. So that is the principle of a strain gauge. Strain gauge is nothing but a resistive transducer. Hope it clear, right? Nothing is the resistive transducer, right? Now write out the working principle. In a metal conductor, when stretched or compressed, its resistance will change. Right? So this is the principle. In a metal conductor, when it is stretched means you are applying a stress or a strain, you are applying a force. Compressed means also we are applying a force. So with that, the metal conductor's resistance will change. We'll see how the resistance will change. Alright, the resistance will change. If you measure the change in resistance, definitely, so whatever the output voltage that you are getting from the changing resistance, that is analogous to the whatever the stress or strain or a force that you applied. See, but suppose how the strain gauge means. Strain gauge is nothing but one wire, twisting wire. Right? So this is nothing but a strain gauge. It's nothing but a metal conductor. Right? If you stretched, that means you another force that you applied. So what happened if it is stretched or compressed? Its resistance will be changed. Initially, its resistance is 10 ohms. When you stretched, your resistance will be increases or decreases. It initially is 10 ohms, right? If a force that you applied, either stress or strain that you applied, so definitely your resistance will be changed. How much resistance will change? The resistance is up to 100 ohms, right? So the resistance will be changed. How the resistance, change in resistance can be measured with the help of Wheatstone bridge. Initially, how the Wheatstone bridge like this. R1, R2, R3, R4. Here a galvanometric deflection. If R1 is equal to R1, R3 is equal to R2, R4, it will show the null deflection, 0 volts. Right? So whatever the resistance changes, there will be a change in resistance from 10 ohms to 100 ohms. This change in resistance that you applied across R1. Right? So if when you apply this thing, this total resistance will change now. Right? So when resistance change means this relation should be violated now. Right? So then this galvanometer deflection will show some value, not 0 volts. It shows some 5 volts. Right? So whatever the 5 volts, which is analogous to the change in resistance now. How the change in resistance happened? By applying the force now. Right? So that means whatever the force that you applied, whatever the strain, force, strain, stress, stretch, compress, whatever it may be, the force, strain that you applied, which is analogous to the voltage that you are getting. So in this way, like this way, your strain gauge will work. Strain gauge is nothing but a simple construction. One metallic conductor is going to be stretched or compressed. Your resistance will be changed. We'll see how the resistance will be changed. Alright, so this is the working principle of a strain gauge. I hope it's clear. A strain gauge is nothing but a resistive transducer. Alright, so what is the definition? What is the working principle of a strain gauge means? In a metal conductor, when stretched or compressed, the resistance will be changed. So this is the working principle. So when change in resistance, you can find out the change in resistance with the help of Wheatstone bridge, or else whatever the resistive measurement techniques. Alright, so whatever the voltage that you are getting, which is analogous to the stress or strain that you applied. Alright, I hope it's clear the total working principle. Up to now, this is today's session. So what we discussed means what is the importance of strain gauge, right? Where we can use aeroplane rings, weak points in the bridges, right? Track to works, right? So how much weight that the line should carry, right? These are the placement where we are using your strain gauges. Introduction part that we discussed. After that, what is a strain gauge? What is a working principle of a strain gauge that we discussed? Right? I hope it's clear. In the next session, we will discuss about how the resistance will be changed. Right? After that, we calculate the gauge factor. Right? So with this, we will finish your strain gauge concept. What are the metals that are used? Metal conductor is there now. What type of conductor metals that can used, we will discuss about. Thank you for now.